Good. Okay, so please mute yourself and I will start. So today I probably will start with this PowerPoint, which is many different topics. So just a reminder, this is lecture 9 from the series about data architecture. And this particular PowerPoint covers multiple topics. Okay, I don't know how to do it right. So we'll start with ETL, Git, continuous integration development, DevOps, YAML, fuzzing, protocol buffers, and high availability clusters. So it's all over the place. But these are the terms which data architect should know about. So ETL, extract, transform, load, and usually it's a good idea to avoid chains. Like here you have A, data goes to B, data goes to C, to D, to E. I've seen chains more than 30 servers, and this is a really, really bad idea. The much better approach, if you take all your data sources, unload them into some processing area, so files, then some processing, output files, and then load them in output targets. Some of the output targets may be also input targets, like you see B, B, C, C. So instead of a chain, you have like a central place for processing. This scales well, and that's what you usually should at least try to do. Hi, Rachel.
Hi.
Hi, let me decrease this. Okay. So this is basically a FedEx architecture. You know how, please mute yourself.
Yep, just did.
Yeah, how FedEx works, that planes from all states go to one airport at night, and then they exchange letters in one place. So this is like a, I don't know, Texas airport, or I don't know, Chicago. I'm not sure where. They have not one, but several airports where they exchange. And then you fly back to your state, right? So this is FedEx architecture. Okay. Another important thing about ETL is that individual steps should be rerunnable. And this is very important because things go bad. The network outages, server outages, the corrupted data, whatever. And if something goes wrong, you should be able just to rerun the scripts. You should not go with your hands and run some, I don't know, updates or deletes manually in the database. So the scripts should be able to clean and to reload in a clean way by themselves. Okay, think about moving data as a big set of distributed transactions. Expect that individual steps often fail. All steps should be logged. Of course, you should have log files, and logs allow the design system to do self-recovery. Well, it's either logs or like how you load the data by steps. But anyway, all rows of data should be tagged with individual row ID, individual unique load ID. So it's like a batch ID, a timestamp, user who is doing the load, and some other metadata, which will help if you need to clean or rerun something. Use bulk whenever possible. So you always want to go for bulk because sending piece by piece takes a lot of bandwidth. I mean, it's difficult. Today, people do that. People use messages, but every time when you can use bulk, like big files, use big files. Not huge files, but well, big enough. So there is usually some sweet spot. Split huge chunks of data into reasonably sized pieces. Oh, okay. What I just said. In case of failure, smaller pieces allow to rerun only the failed pieces, not the whole thing. Yes. So for example, if you need to load data for the whole month, maybe you can load in daily chunks or even split like 6 hours of data at a time, depending on your data. Do all processing externally in ETL layer. So this is ETL layer. right? I know nowadays people try to do what's called ELT, which is extract, load in the database, and then transform. And this actually existed 20 years ago and probably even earlier. And yes, it happens, but it should not be probably like the main way how you do ETL. So try to avoid post-processing in the target. Well, again, you can do it depending on the situation. When loading into databases, disable triggers, drop indices, and so on. So you drop indices, you disable triggers, you load the data really fast, and then you recreate the triggers and maybe re-enable re-enable triggers and recalculate statistics on the table, recreate indices and so on. Monitor memory usage to avoid crashes. This still is a problem with a lot of ETL systems. They don't monitor the memory and they crash. And like you really, when you deciding how you do the load, always pay attention to that. And if you have ETL scripts, always check for the memory from inside the script. If you, I mean, I've seen things happen because, for example, people have some server which is running a lot of loading jobs, and of course, people schedule them to run on the top of the hour or on like 30 minutes on the bottom of the hour. So many jobs start at the same time, overload the server, it runs out of memory, things crash, and okay, so it's important that system should be intelligent enough, and if it's not enough memory, it wouldn't even start the process, maybe try to delay it. It's not difficult to arrange. It just, you need to take some care of this. Okay, ETL continued. Microsoft SQL Server on Azure Cloud, standard SQL database, more than 30 years. Okay, Power BI. This is just a link how fast Power BI works with a lot of data rows. Well, you know, Power BI is good. This is another demo of KineticDB. So KineticDB uses GPU, and it's also very fast. Microsoft SQL Server is not the only fast server. There are other solutions. So you have sub-second response of billions of rows of data, no need to create indices, no wait time, and so on, right? So there are some benefits. Okay, next, I switch to Git. So Linus Torvalds, who is famous for two pieces of software, Linux and Git. And he jokes that he named them after himself, Linux because he's Linus, and Git because this is like a slang expression for unpleasant person. So he is known to showing people a finger and accusing them and telling them what he thinks about them. So eventually the community kind of pushed him out. So he's rude, but he's brilliant, of course. So he created Git, 16 years ago in 2005. Before, Linux community was using Bitkeeper, so they switched to Git. And the thing about Git that this is distributed system. At least all that I know, source control systems which existed before had a central server where people were submitting their code. Whereas in Git, it is distributed. Every developer has his own repository. They can send the code between themselves, so they can submit it to their, let's call it manager, and then they can merge into some central location. Okay, so Git is a very good system, of course, like everybody is now using it. So this is Linux, this is Git logo. This is GitHub. So this is a company created in 2008. And now it's a huge company. You see 2.5 thousand employees, whatever. So it was acquired by Microsoft for 7.5 billion 3 years ago. And we're using it, right? And in Microsoft DevOps, Git is behind the scenes. So it's the most used source control system in the world. And frankly, only probably in the old financial applications, you would find some other source control systems. Everybody switched to Git. It may be GitHub, it may be GitLab, it may be some other incarnation of Git, but Git is everywhere. And here I just provide some links and some common commands, like how you create a .git config file, git excludes, git completion.bash. I really love this file. This is how you clone the directory, how you commit something, how you push it to your like online, let's say it's GitHub, your repository, fetch, pull, log. There are a lot of commands. And if you go to this documentation, there are some nice tutorials. And of course, there are lots of tutorials on YouTube. It's easy to use, but also it's quite complex because it has branches. You have to be careful. Usually when I work with people, I warn them, please don't use advanced features. I mean, Linus Torvalds and his generals created them because they had a very complex system to deal with. They have to switch between multiple versions of the code, the multiple pieces of the code. We usually don't have to do it. And it's better to avoid this unnecessary complexity because people usually don't have very high IQ and they create problems. So it's really better just to use the basic functionality, like practically. This is an example of a git config file. I actually copied my own file. So you see, you can create aliases, for example. So instead of do git commit, you can do git. So you see this command git commit with some comment. You can do git check-in, CI, and so on, whatever. Next is DevOps. So DevOps is a big term, right? So it's a development and operations. So it's a people, processes, technology, quality engineering, security, all together. In Azure, we have DevOps Server, which combines many tools to do DevOps in one place. In other clouds like Amazon and Google, they also have DevOps tools. There are multiple different tools. Okay. Continuous integration, continuous development. Again, there are multiple tools to do that. Sometimes in some organizations, I've seen that they really help. In some organizations, they just create problems. For example, if you require people to do continuous testing of your code, but your development infrastructure doesn't work, there's always network problems and whatever, it's not reliable. So you cannot really test all the time. It's actually slows you down. But in big companies like Google, for example, where you have tens of thousands of software engineers committing all the time, or Facebook, or like whatever, they have to do it. And their testing infrastructure is extremely reliable, and it's bigger than their production infrastructure. So it's really interesting how this works. So there are multiple packages like Circle CI, Jenkins Server, Travis CI, CodeSheep, TeamCity, Bamboo, and so on. Anyway, just for your information, you can review these links later. I will post them and send you email. YAML. If you haven't used YAML, you have to learn how to use YAML. YAML was created 20 years ago. Originally, name means yet another markup language, but pretty soon it was renamed to YAML ain't markup language because it's generally is like a tree structure for configuration. So you can record data as a tree. If you look at JSON, JSON is good, but JSON is not really designed for human use. Like, for example, you cannot create comments in JSON. YAML, you can do comments. So this is an example. And comments, like in Python, it's just pound. You can do nesting by just using indentation, the same way you would do it in Python. And in YAML, you don't use tabs. So this is very simple. You see Martin, or you see Tabitha, and whatever. So you have some structure of this object, right? And you can separate things by 3 dashes. You can actually use JSON inside. So JSON is actually valid YAML. But YAML also allows for more convenient and more visual representation. right? And from Python, it's very easy to use YAML. So here's an example. You do pip install py-YAML, and then you import it. And with open file, you do YAML load of this file, and you can print it. Or if you have some data, then you can open file for writing, and you do YAML dump, right? So it's really, really easy. YAML was originally created by 3 people. I here found the pictures. And the last one, Oren Ben-Kiki, he's in Israel. Others are in US. And these are their pages you can explore. All very talented and actively working people. So the reason why we like working with YAML is because it's optimized for data serialization, formatting, dumping, configuration files, log files, internet messaging, and filtering. That's all true. There are many advantages of localizing files in a YAML file. Files are easy to work in a text editor. So this is actually the main and only advantage of YAML, right? It's really easy to learn. If you go on YouTube, you can find tutorials which may be 5-10 minutes, and that's all you need to learn YAML. It's simple to use, so I highly encourage you. And by the way, modern DevOps use YAML all the time, so like things like Kubernetes or whatever. So just learn YAML, start using it. Fuzzing for test automation. Oh gosh, the idea is that you try to break application. So application has some input, and you try to change the input, trying to make application to crash. So this is the idea of fuzzing, right? So originates from 1988. There was a class with this professor, Barton Miller, University of Wisconsin, and they were trying to crash Unix utilities. So it's interesting, it was educational project. At Google, they use fuzzing all the time. All the applications go through extensive fuzz testing, and there are packages of like you can learn more about fuzzing, and these are different strategies how you do fuzz testing. So this is like some chronology. So here you have 2016 DAPRA, which is Defense Advanced Research Project Agency, competition for developing automatic defense systems that can discover, exploit, and correct software flaws in real time. Used fuzzing as a offense strategy to discover flaws in software of the opponents, right? Security bugs in software. OSS fuzz, Google, continuous fuzzing of security critical open source projects. Black Hat 2018, Christopher Dormers demonstrated the use of fuzzing to expose existence of hidden risk core in a processor. This core was able to bypass existing security checks to execute ring 0 commands from ring 3. Whatever. So it's a fascinating thing. It's a fascinating technology. I highly recommend you to educate yourself about it and maybe use it, although it's mostly used when you create, like if you're a software developer, right? And you're creating, I don't know, Chrome browser, you have to test it, right? Okay, protocol buffers. Again, terms comes originally from Google. And the idea is you have a header and the data. And the header describes the data. So it's how you serialize and send the data. And protocol buffers allow you to be flexible. So you can describe any kind of data in any format you want and create this protocol buffer and then exchange these protocol buffers between applications. It is open sourced, so you can use it. Okay, next, high availability clusters. So the idea is that if you have a server, it may fail. So what do? You take another server. So you have master slave. So you have 2 servers, and then maybe you put a load balancer in front of them. But then the question is, what if this load balancer will fail? So you think, okay, how to improve that? And then if you have layers of clusters, how you connect them. And in each layer, you may have some fails. So you go from master-slave architecture to consistent hashing, which I already discussed earlier in some lecture. So you need to have a failover mechanism between the servers and the layers. You need to use some sort of heartbeat mechanism to identify the servers which are failing, to remove them, and so on. So it's a interesting engineering project, how you create a system which is highly available and reliable. And here I go into some explanation of consistent hashing. I believe I went through this in one of the previous lectures, so maybe I will not cover this because we have some other material to cover. Okay, so this is this slide. Next, I want to talk about Docker. So I actually very proud of this presentation, which explains what Docker is, and it has like a small tutorial which you can use if you never use the Docker. So the idea is you have virtual machines, right? It is operating system software which initiates working, blah, blah, blah. So you know what it is. Then Docker container, you can think of it as a very light virtual machine, right? It's like virtual machine, but usually much smaller and lighter because it doesn't have to include the whole operating system. The whole operating system may be, I don't know, 2 gigabytes or maybe more. But for some application to work, you may need maybe a minimal operating system, or maybe even no operating system at all, because you can use external operating system. So inside the Docker image, you can put only the application itself and only the libraries you need for this application. So the Docker is like a miniature virtual machine, effectively. And on the same physical server, you can run multiple Dockers, whereas VMs, how many VMs you can run on one machine? I don't know, just few, but Docker containers, you can run hundreds. And this is what used extensively. Inside the Docker, you can put database or any kind of application. And then you use Kubernetes, which is Healthman, like software to deploy and manage multiple Dockers together. So, for example, you want to deploy 10 applications on East Coast, 10 applications on West Coast, another 10 applications on, I don't know, in Europe, and another 10 in Asia. And Kubernetes allows you to orchestrate all that and also monitor their performance. And if some of the Dockers go down, to substitute, like maintain a number of available applications. So this is Kubernetes. And then Istio yachting, right? It's a proxy on top of Kubernetes. It adds service discovery, routing, security policies, failure handling, logging, tracing, visibility, connect, secure, control, observe. Well, Istio is when you have a lot of applications running in different places, and you don't even have to know where they are because Istio will discover them for you, like a directory. But this is for usually very big systems. Okay. So the path is from dedicated on-premises server to virtual machine on the cloud, to Dockers, to Kubernetes managing those Dockers, to Istio, which is like a service mesh with a lot of different services, to serverless architecture, microservices. I'm not sure what's the difference between the last two. I think functionally it's about the same. Okay, Docker containers. So the containers originally, I think they were first created on Google. So the idea was how you run applications on the same machine so that they will not interfere with each other, how you achieve certain level of isolations, right? That's how virtual machines appeared, and then Docker as a lighter version of them. And then a company was created, Docker, in 2013 in California. So now it's pretty big, and they have a website where you go and you will see a repository of a lot of common containers, and you can create your account and you can upload your own containers, and other people can use those containers. So for example, if you need to start a container with Linux, you don't have to create it. You can just use it. And then use one of the containers available on this website. And then you can add something to this container, like, for example, a certain version of Python. So if you go here, you can find a ready-to-go container which already give you like minimum operating system and then, let's say, MySQL database or Python or whatever combination thereof. And then you can start with one of those Docker files, and then you can add some custom functionality which you need, maybe your own script, your own modules, and so on. So Docker history: containers grew from Linux development, blah, 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 namespaces, control groups, union file systems, chroot and jail 82, engineers at Google. Oh, okay, I even have the names. This file was created, by the way, like a couple of years ago, so I may not remember everything that is here. Started to work on control groups. Docker is written in Go language. Okay, understandable because Go was also created at Google. So early versions, Linux containers, Docker, and this is very nice article on minimizing the size of Docker image for Python application. Okay, so you can follow these links to educate yourself. So here are some typical commands. I will not run them because on this computer I haven't installed Docker, but here what you can do, so you have Docker somewhere in your path, like user local bin Docker, and you can run Docker version, Docker run, and some name. And what it will do, it will first search locally on your computer. Maybe you already have a container with this name. If it cannot find it, it will go to some standard places to search for this container, download it, and run it. So once you have some applications running, you can do Docker ps, which is like processes -a. So it's like a Unix command. And it will show you all the containers. So here's, for example, the output of a command like that. So you see that we have a container running, image name hello world. This is the command. When it was run, exited, whatever. And yeah, you can give it your own name. So you see run as name my hello world, right? So here is my hello, and this is the name of the original image. And this is another command, docker run -it name my Linux container Ubuntu bash. So it will load a container with the name Ubuntu from some standard repository, and it will start it, and it will end it, and it will run bash command inside. So here, boom, you are inside the container, and you can run all kinds of commands. Okay, very easy to use. So here you create two Linux containers. Here you do something interesting. You execute command bin bash inside one of those containers. So you effectively enter the container, and then you can do something. Okay, and then here you remove and so on. So the pages after that show you different kinds of commands you can do, how to work, and you can play with it. So Docker itself runs in its own virtual machine, and it stores images inside it. So for example, on my computer, okay, this was 2 years ago, it was taking approximately 64 gigabytes, right? And okay, so these are some commands, more commands about Docker. It's not difficult. Once you start working with it, you get up to speed like in a couple hours, and then you're flying. Not difficult at all. Okay, there's more links, so you can review it at your own time. And I have just a few minutes left, and I have one more, just few more slides. So first, about security. We know the importance of this, and how you achieve data security, how you regulate access. SSO, single sign-on. So the idea is very simple. First, you log in into some system. It has some identity provider some server which identifies, yes, you are a good person, you have the right, and you authorized to do something, and it gives you some token, right? And the communication may go using SAML. SAML is security assertion markup language, which is basically XML. So here is the example of some SAML message. So it gives you something, and this something is usually a token, right? And then you want to access application. So you send your request with this token. So now this application, the service provider, can ask the central server, I got this token. Is this token valid? The token may have some lifetime, let's say 30 minutes or whatever, after which it has to be renewed. And it checks and say, yes, this token is valid. And yes, whoever has this token should have access to this application. Because maybe if this user will send request to some other application where he is not authorized to use, it will check with the central server and it will say no, have no right. So this is kind of standard SSO, how it works. There is a three-legged where you have three parties, like here. You have user, you have server, and you have application, right? This is usually how it works, and it's called a three-legged scheme. But there is also a simplified two-leg scheme where you don't check the user. You just check if application, like for example, I don't know, you have a server and you have a database. And whoever has access to the server automatically have access to the database, something like that. So they can just kind of short-circuited between them. So term two-legged is used to describe authentication request without the end user involved. So whatever. So there are some resources here. Next is GDPR, which stands for General Data Protection Regulation. It's a European regulation. We still, I believe, don't have similar regulation in America, although people just use the one from Europe. It took many years to create this regulation, and it regulates, you see, there are things like data protection officer, right? Some compliance requirements, data, what is this? I don't understand. Oh, what you do when things break and how you lock your data. It's a big regulation. You may read it or listen some YouTube tutorials about it. So it's a good to know. I have a relative who is on like a big lawyer at Facebook, and he says that most of his time is dealing with GDPR. So this is Facebook. Okay, and there are some resources about this regulation. Okay, these are people. Okay, this is father of SSL, right? And this guy is SSH protocol. Okay, there's a lot of terminology about encryption, OpenSSH, and so on. I will not go into this, but you can like follow some links here and some history of the subject. And then I have only 1 minute left. Is a few words about SQL Server data security. And there are so many ways how Microsoft helps you with security. For example, here the pictures of dynamic data masking. So you can use firewalls, VPNs, whatever. You can see this list. I will not go through it. But you just need to know that there are many ways how you can protect your data. And as a data architect, you may go through this list and recommend your clients what to do. Okay, I'll stop recording, although I don't know how to do it.